coordinate grid is comprised of two number lines, the x-axis and the y-axis. And these two axes intersect to form a grid, which is laid upon a plane, and the grid is used to locate a point on that plane. And we locate points on that plane by their coordinates or their ordered pairs. We're going to take a little bit deeper look at this coordinate grid because now, as you'll notice, before when we worked with the coordinate grid, we worked with all the x values were positive and all the y values were positive. Now that we've talked about negative numbers, the x and y axis can extend into the negative direction. And that does something to our grid. Now our grid gets larger, essentially, but our grid is also cut into 4 separate parts. These separate parts are what we call quadrants. And the quadrants are numbered 1, 2, 3, and 4. The only difference is that we use Roman numerals to notate the quadrants. Just as before, when we plotted a point on the coordinate grid, to locate that point, to label it, to determine its ordered pairs, its coordinate, we would trace it back to the x-axis and then the y-axis because ordered pairs are written in that order, x, then y. So this point here is located at 3, 4. The difference now is we have 3 more quadrants that we can plot points in. And if you look closely enough, we can determine which quadrant a point is located in by the values of the x and the y. When we look in the first quadrant, as I've already stated, our x values are positive and our y values are positive. When I come over here to the second quadrant, look closely, we see that our x values are negative, but our y values are positive. And then down here in quadrant 3, we can see that our x values are negative and our y values are negative. And over here in quadrant 4, our x values are positive, but our y values are negative. So by locating them, by looking at their values of the x and y coordinates, we can determine which quadrant a point is in. So for instance, the point 3, -5. It's a positive and a negative, and when we look, quadrant 4 is a positive x and a negative y. Or -2, -6. -2 is this way on the x-axis, and -6 is down this way. So that point is located in quadrant 3. Otherwise, plotting the points the exact same way as we were working over here in only quadrant 1. Again, the first value is the x value, the second value is your y value. So if I want to plot 3, -5, I go 3 along the x-axis, and I drop down 5 units in the negative y direction. And we'll call this point B. And then this point can be C, -2 in the x direction, -6 in the y direction. And just to kind of close it all up, we can plot a point in quadrant 2. We'd have to have a negative value first, and then a positive value. So -4, 1. And that's point D. So by looking at the value of the x and y coordinates, we can determine which quadrant a point is located in. Okay, one other thing about working on the coordinate grid is when we look for a location, what quadrant it is in, we have the times where a point might be located on the x or y axis. When a point like F or the point like G are located on the x or y axis, they are not in either quadrant. So G is not in either quadrant 3 or 4, and F is not in quadrant 1 or 4. We state that they are located on the axes. So F is located on the x-axis, and G, we would say, is located on the y-axis. So now, let's talk about what else can we do on the coordinate grid. The other thing we can do on the coordinate grid, or that we're going to look at, is focusing on plotting a polygon, in this case a parallelogram, on the coordinate grid. And then once we plot our parallelogram on the coordinate grid, we find the area of this particular parallelogram. And if you remember, area of the parallelogram is equal to base times height. Okay, so I have 3 points here. X, which is located at W, which is located at -3, -2. X, which is located at -1, +2. Y, which is located at 6, +2. And then the question is, where would point Z to go to make this a parallelogram? So we know that these are already points on a parallelogram, so they're going to form 2 of the sides. Let's draw those in. Now the question is, where will Z go? Well, if you notice, this XY is on the same grid line. It is on the same line where Y is equal to 2. Okay, so for W, the line that's parallel to Y is equal to 2 is here, where the Y value is -2. So we know that this line is going to be the other line of the parallelogram. The question is, where do we put Z? Where along this line? The easiest thing to do is look at X and go into W. How do you go from X to W? Well, I need to go back 2 to the left and then down 1, 2, 3, 4 units down. So from Y, I'm going to do the same. Back 2 from Y and then down 1, 2, 3, 4. And that's where point Z will be located to make this a parallelogram. So there's my parallelogram. Now, how do I find the area? Well, I need to find the base and the height. Well, these 2 lines here will be our bases. So when you're working on the coordinate grid, if you can make the base fall on either the horizontal or the vertical grid lines, that's the best thing to do. All right, so our base. So one of these 2 line segments here are our base. Let's just look at this one. So here we are 1, 2, 3 units away from 0. And here we are 1, 2, 3, 4 units away from 0. So we take the absolute value for our x values, -3, and here +4, 4, -2. We add them together, that's 7. So our base is 7 units. You can just count also 1, 2, 3, 4, 5, 6, 7. And our height, again, remember, height falls the distance between the 2 bases in a parallelogram along a right angle. Okay, so we're 2 units away from 0 here, and then 2 more units away from 0 there, for a total of 4 units. 1, 2, 3, 4. So our height is 4 units, and area equals base times height. So in this case, area equals 7 times 4, which is 28 square units. Okay, so that's a real quick look at how we could plot a parallelogram on the coordinate grid, and how we can use the grid lines to determine the area of that particular parallelogram.